who brings an extraordinary set of experiences to his current position as Director of the Launch Systems Enterprise Directorate, Space and Missile Systems Center, Air Force Space Command. This demanding position includes leading the acquisition, integration, development, production, operation, and sustainment of the EELV launch vehicle program, the Evolved Expendable Launch Vehicle program, and the Rocket System Launch program. So we did provide a very detailed bio in our introduction for the Colonel, but I just did want to mention his impressive range of experiences from within the Undersecretary of Defense for Acquisition to the Chief of Staff for the NRO's Office of Space Launch, and as Air Staff Program Official for the EELV program. And he's had multiple other related program management operations assignments. It's really hard to imagine anyone better prepared for his current responsibilities than our speaker today. The broad footprint of the Colonel's office on our space community is such that while companies such as ULA and SpaceX are contracted to conduct key national security missions, the Colonel has stated that SMC intends to partner with industry to invest in the next generation rocket engine testing, upper stage resilience enhancements, and orbital transfer and maneuver capabilities. These enabling investments are part of the National Security Space Launch Phase 3 strategy. And we're looking forward to hearing more about that from Colonel Bongiovi today. So with that, the program today is entitled How Cutting the Cost and Time to Deploy Spacecraft May Revolutionize Military Space Planning. And so with that, I would like to pass it over to Colonel Bongiovi. Thank you.
Thank you, Sally, and good morning. I'd like to thank the Washington Space Business Roundtable for the opportunity to share with you the hard work of the United States Space Force's Launch Enterprise team of nearly 800 people, the work we're doing every day to ensure mission success. And the Launch Enterprise is, as mentioned, is part of the Space and Missile Systems Center's Enterprise Corps. We provide affordable, reliable access to space when and to the orbits required for our nation. And you know, space, I'm sure everybody here understands that space is essential to our nation's security and prosperity, and unfettered access and freedom to operate in space is a vital national interest. Before I go any further, I'd like to say the United States launch industry is the envy of the world.
Here up, and I don't get it right.
The United States space launch industry is the envy of the world. We're proud to continue our industry partnerships and investments. These successful partnerships are, in my mind, are critical to retain the United States' preeminent space launch capability. So Launch Enterprise provides the launch capability across the full spectrum to meet the needs of our national security and intelligence community customers. We provide ready access to everything from small launch and targets for experiments to demonstration and operational missions to the large rockets launching the most complex and demanding payloads in the world. We also have, to do this, we have multiple flexible contracts that provide affordable, responsive, and frankly, frictionless access to launch services for all of our customers. We do everything. We lead the launch effort from initial research and development investments, partnering with industry to develop new capability, the procurement of the launch system, mission assurance, and then the actual launch operations through satellite operation separation and the maneuvers that we do to ensure that we minimize orbit debris for future protecting the global commons of space. The largest program in the Launch Enterprise is the National Security Space Launch Program, which used to be called EELV, or the Evolved Expendable Launch Program. NSSL provides the assured access for our nation's most critical warfighting space assets. These are things like our nation's eyes and ears, our secure communication for all levels of conflict, our positioning, timing data, and all of our space warfighting capability. We're able to launch successfully and to the point in space when needed, but these launches can't fail. So our hard work and vigilance has resulted in an unprecedented record of success for our missions of 86 successful launches out of 86 attempts. With these recently awarded NSSL Phase 2 contracts, we're implementing the last step in to end the reliance on the Russian rocket engines. We're also developing 2 independent families of launch vehicles, making sure we have 2 independent families of domestic launch vehicles. We're cultivating competition, and most importantly, this contract is a huge success story. So I'm going to talk a little bit about it. The approach that we use achieves the lowest overall cost to the government while providing this assured access, reaching the more demanding orbits with greater mass than most commercial launches, and integrating these complex satellites. In the last 8 years, we've reduced our life cycle costs through 2030 by $22 billion. This is a 28% unit cost decrease. And I just want to point out that this decrease is using the same calculations that are used for non-McCurdy breaches. So this is a key parameter, and what it represents is it represents less demand on future budgets for launch services. We've also achieved real savings by working with the Space Force, OSD, the Office of Management and Budget, Congress, to reallocate over $7 billion of savings. These were funds that were already allocated to the NSSL program. And we were able to reallocate them to other warfighting capability or other national needs. In other words, in addition to getting prices that reduced our future estimates, we actually were able to take money that was already earmarked for us in the budgets, and then allow that to be or provide that back so it could be used for other national priorities. So that's a huge deal. Finally, we've achieved competitive pricing across all launch vehicle performance regimes, which cuts launch prices for our most demanding missions as well, the ones, frankly, that most of our customers need by over 50%, while obtaining commercial-like pricing for commercial-like launches. The fact that we are able to partner with the launch industry to extend affordable commercial capability to demanding orbits is a key point that's often missed. The emerging threats drive national security satellites that demand more capable launch vehicles than most commercial satellites. We saved the government a bunch of those savings were because of the reducing the prices of the higher energy orbits by tens of millions of dollars while getting the commercial pricing on the lower energy orbits and actually leveraging the launches we do to lower energy orbits to keep the overall price down. But we can't afford success at all costs. That's why we work hard to create strategies that leverage commercial innovation and follow sound business practices. So the Phase 2 contract really has some really neat features. It has a responsible, resilient ordering and integration process. Missions can be ordered and launched within 12 to 24 months of the order, and that's well within the time frame most of our customers need. It funds something called launch service support that provides the backbone capability to meet national security needs and avoids providers having to pass national security unique costs onto their commercial business. Ensuring that the unique national security costs don't bleed into the commercial products is important because every launch that a launch provider does that's not a national security launch also reduces national security costs in the future because it allows them to create more efficiencies and give us lower prices. So this is the type of creative solutions that make industry partnerships successful. Phase 3 does implement a robust and affordable mission assurance process, and that's been proven to deliver on-orbit capability. Our mission assurance process enhances mission success. On average, if you look at the data, about 1 out of 12 commercial launches fails, but NSSL has a perfect record. But our mission assurance is also cheaper, really, than commercial insurance. The average cost of an NSSL mission assurance is about 3% of the total satellite and launch vehicle cost, or what we call the stack cost. Whereas commercial insurance premiums currently appear to average about 7% of the stack cost. And as an aside, even if we could use commercial insurance, it would not meet our intentions of enhancing mission success. We're paid to put capability on orbit, not generate revenue or profit. So without that bottom line, it makes more sense to use our proactive approach, mission assurance, that prevents launch failures than a reactive approach like insurance that mitigates the loss of revenue for profits if a failure happens. Finally, I would say the need for high reliability is not going away. Building out the nation's space architectures that we're going to need in the future requires highly reliable systems to populate them. As has been mentioned before, and as I said at the beginning, our launch industry is the envy of the world, and our industry partners are providing the innovative solutions that benefit national security space launch. So on the National Security Space Launch Program, United Launch Alliance has shown remarkable innovation by having a single factory that supports 3 launch vehicles, a single pad that supports 2 launch vehicles, and a single booster core supporting all of our NSS needs. That last one, a single booster core for all NSSL needs, greatly reduces the cost and complexity for launches to our most used higher energy orbits. SpaceX has shown equally remarkable innovation with booster recovery and reuse on their Falcon launch systems that also reduces costs and allows us to have an increased launch tempo. We have fully incorporated reuse into our NSSL program, and the upcoming GPS 3.5 launch, in fact, our next NSSL launch, is going to be the historic first use of a previously flown Falcon 9 rocket on an NSSL mission. But I have to tell you that although we awarded the Phase 2 contract last summer, the hard part of Phase 2 is just beginning. For the first time in NSSL history, or ELV history, we have 5 distinct launch vehicles on contract: the Atlas V, the Delta IV, the Falcon 9, the Falcon Heavy, and the Vulcan. We have a demonstrated record of success on the Atlas V and the Delta IV, but we need to stay focused on maintaining that success as we fly out our missions on them. At the same time, we're at the very beginning of the mission assurance process for the new launch systems. Thus far, just a scorecard here, thus far the National Security Space Launch Program has only flown 3 times on Falcon 9, although SpaceX has flown almost 120 times. There are on a Falcon 9. There have been no Falcon 9 Heavy NSSL launches, and SpaceX has only launched Falcon Heavy 3 times. And of course, Vulcan hasn't flown yet, so there's been no NSSL launches. The first launch slated for later this year, early next year. So that's, there's a lot ahead of us on Phase 2 and transitioning the payloads to new launch vehicles. So we must stay focused on launch success. There's a ways to go in Phase 2 before the program really provides all the information that we're going to use to develop the next strategy and partner with industry. But talking about the future, once we successfully transition all these payloads to our new launch vehicles and have demonstrated a record of success, or at least an initial record of success, we'll have a solid baseline for the future. But even with that baseline established, we're going to need some level of investment to continue to ensure commercial launch systems can meet national security needs. We've taken the first steps with the Phase 3 initial enabling investments in prototype projects for next generation rocket engine testing, for upper stage resiliency enhancements, and for orbital transfer and maneuver capability. These first prototype projects will be awarded using SMC's Space Enterprise Consortium, or SPEC-OT, and we're going to do that by September of this year. And we're going to work with industry to develop and all of our stakeholders develop the Phase 3 strategy. But in the end, in 2025 is when we have to have the next strategy in place. And I'm sure that a couple key parameters are going to be in there. We're going to use competition. We're going to continue our very successful public-private partners, and we need to do all that to assure U.S. access and freedom to operate in space. So while NSSL is our large program, the SMC Launch Enterprise also intends to go big with small launch, and that small launch industry also provides eye-watering innovation day in and day out. We work with new innovative launch providers to bring on capability that will enhance our resiliency, our flexibility, and our responsiveness. We provide flexible mission assurance and can procure anything from a ride share to a sounding rocket to an experimental larger rocket. The program that we have has had over 700 successful launches since its inception in the 60s. And the most recent was just in March, where we launched the Space Vector TTO sounding rocket in support of an AFRL experiment out of Wallops Flight Facility. That's in Virginia. Small launch is also a hotbed for energizing the business sector and tapping into their innovations. For example, last year we used Space Pitch Days to award 2 small business innovative research contracts to non-traditional small launch startups, Launcher and Adrenas. The Launcher is working on the world's largest 3D printed liquid rocket engine. Adrenas is developing a high-performance, clean, solid rocket fuel. And this is just the tip of the iceberg. We have strong partnerships with Defense Innovation Unit and Space Test Program on experimental launches for a number of new providers like Vox, Rocket Lab, ABL, and other emerging providers. We're very involved in working with them to understand how those systems are coming along. We also employ innovative acquisition approaches and non-traditional contracting strategies to ensure rapid and agile execution of small launch contracts. For example, my team awarded a suborbital launch service for the Buzzard mission just 2 weeks from proposal receipt and launched it in only 9 months. That same team also awarded an orbital mission to startup launch provider in just 3 months. These are months faster than what we used to do, and this is quickly becoming the norm, not the exception. I'm very encouraged by the vigorous competition in the small launch arena, and we look forward to continue to use that to get innovative launch services. Our largest small launch contract, Orbital Support Program 4, OSP4, we open that up for every year for potential on-ramps opportunities, and that's to get emerging launch providers and increase the pool of eligible vendors, increase competition, get more innovation. So I'd like to wrap up my discussion of the small launch by discussing tactical responsive launch. The tactical responsive launch, in my mind, is not a launch problem. We've demonstrated over and over that we have multiple ways to launch in the required timelines. What must be demonstrated is an end-to-end capability that includes the satellite and the payloads, the ground systems, the policies, procedures, and required operational decision maker. And I'm really proud of the progress being made by tactical responsive launch efforts across all these areas, and I think Congress providing the funds needed to facilitate those types of demonstrations. The last area of launch enterprise I want to highlight today is the Mission Manifest Office. It's one of our most exciting changes, and in the last 3 years, that little office has changed the paradigm of launch. In August of 2019, on the AHF-5 launch, for the first time, we deployed a secondary payload, which in that mission was called TDO, before we deployed the actual national security primary payload. TDO was a 12U CubeSat carrying a space debris investigation and tracking experiment. Since then, we've done that 2 more times, on AHF-6 in March, and just yesterday with the SBIRS GEO-5 launch. And the MMO team has also demonstrated the ability to swap one of those small payloads out as late as 1 month prior to the mission. We did that in AHF-6 to show that we can do it. Now, we've teamed up with NASA to populate the ESPA ring, or the secondary adapter ring, on their upcoming Landsat 9 launch. This ring will contain an additional 13 CubeSats ranging in size from 3U to 12U. So that's huge, additional access to space. These are game-changing innovations that afford our customers flexibility and resiliency and maximizes the capability to the warfighter of our access to space. I couldn't be more proud of this organization and their efforts to ensure we fully utilize our launch capability to get as many operational, demonstration, and experimental payloads as possible to space. I always like to wrap up these discussions by summarizing our accomplishments. That's one of the fun things about launch. We get to accomplish things here and there. So I'm going to run through just a few of them. In the last 14 months, we've launched 10 times. In March, we launched AHF-6, which was the first launch for the new U.S. Space Force. And if you remember what's going on in March of 2020, it was also our first launch in the pandemic, and right at the chaos beginning. In May, then, we launched USSF-7, or USSF stands for United States Space Force Launch 7, which we dedicated to COVID-19 responders and victims. In June, we launched GPS-3, which is on a Falcon 9 booster. That was the first time that an NSSL booster was recovered by SpaceX, and so that was a huge mission for us to move towards reusability. In July, we launched NROL, or National Reconnaissance Office Launch 129, which is our first Space Force small launch, and that was out of Wallops. In November, we launched GPS-3-4, and again, SpaceX recovered that booster. But interestingly, because we had contracted GPS-3-5 and allowed or are working on flying the first used hardware, SpaceX retained that hardware for use as GPS-3-5's launch vehicle. So that's a big deal. Finally, in December, we launched NRO 101, which is our first Atlas V launch using the new GEM motors, but those GEM motors are part of the Vulcan system too, so a huge risk to burn down there. And then we launched 2 Delta IV Heavies. These are our most complex and hardest launch. We did them less than 6 months apart. We did NROL 44 from the Cape in December, and NROL 82 from Vandenberg just last month. And then in March, we launched the Space Vector experiment, and yesterday, of course, we had a very successful launch of SBIRS GEO-5. And those are just the launches, right? As I mentioned, we awarded the Phase 2 contract with no protests, and we've awarded 7 missions into that contract, and it's executing very well. Launch Phase 2 weren't the only focus. We've turned up our game on launch reusability. I mentioned that a couple times. Phase 2 is totally open to launch reusability, and that's one of the reasons why we got great prices on Phase 2. But we didn't want to wait till phase 2 launches to do our first recoveries and reuse, so we methodically worked through how we do that without increasing our risk to our critical national security satellites. And then we also ensured the taxpayers retained a good deal they got with those launch services, because those were competed launch services. And in the end, we saved an additional $65 million in those launches by converting from no recovery expendable to recovery and/or recovery with reuse. As we look to the future, our workload just does not go down. Over the next 18 months or so, we're going to focus, of course, on maintaining mission success records as we continue our transition to new launch systems. We could have as many as 6 launches between today and the end of June, 2 of which are our national security space launches. Of course, we want to continue to encourage and develop our small launch industry. There's so much going on there and so much innovation. We want to complete the transition to a reusable SpaceX fleet for our national security space launch missions. We're going to continue working with United Launch Alliance in the Vulcan development and getting to those initial flights. Those are important flights for our non-recurring design validation work. We're going to really start working hard with our stakeholders in industry for the post-phase 2 plan or phase 3 plan. And then, of course, underpinning all this is this space launch industry, and we look to sustain that as the preeminent launch service provider for the world and ensure that it can meet our national security needs. So thanks again to the Washington Space Business Roundtable for allowing me to share the activities and accomplishments of Space Force Launch Enterprise, and thank you to the audience for your time and attention. Open to questions.
Thank you, Carl. Thank you very much. Yes, I actually have a couple of questions, but before I start those questions, I just wanted to make sure that the audience is aware they need to be putting their questions in the chat box. If you could key in your questions and we'll get to them in the order that we receive them. So very impressive set of accomplishments, Colonel Bongiovi, and certainly it seems like there's a lot of paradigm shift going on. I guess you touched on the fact that you have 5 launch vehicles on contract today, and it seems that the Space Force launch opportunities are really only open to those traditional launch service providers. How do you see the Space Force opening up the competitive opportunities for more participants?
Yeah, no, so I mean, we are really striving to promote robust competition across the performance space, small and large launch. That creates and we look to create opportunities for these emerging providers. Again, some of today's NSSL providers weren't part of the program, in the past, but we're already working on phase 3 to figure out how we use more non-traditional capability, whether it's on the prototype proposals, right? We're certainly looking to expand what you can do with the launch vehicles, and that's a great opportunity for non-traditional participants. And then, on the small launch side, again, we very much work to bring on new capability and in fact try to provide business opportunities to enable them to get into operations. So there's multiple opportunities for interest into the overall launch programs. But the one thing I will say is especially as you get into the NSSL class, where these payloads are just not able to, we can't not get those payloads to orbit. We have to balance that with mission success and the complexity of the work, and make sure that we can get these payloads safely. So while we have opportunities and we look for ways to seed industry and to work with industry and to partner with industry to get the capability we need, whether it's leveraging a commercial system to meet national security needs, or on the small side, really trying to just encourage industry to develop the capability and get it into operations. Once we start going into the more operational side of our satellites, we have to balance that with mission success and make sure that we are able to understand the launch vehicle and successfully launch and continue our record of unbroken in our record of success.
So speaking of mission success, you've had an unprecedented launch success record to date, which is very commendable. What do you attribute that historic accomplishment to?
Yeah, well, first and foremost, it's the dedicated and talented team, and not just the team here at Launch Enterprise, which is government and FFRDC and support contracts, but our industry teams. you know, I keep saying it. We have an amazing launch industry, and the success is really due to them. But you know, I think the data really shows that this mission assurance program that was been put in place, you know, was put in place as a result you know, as part of recovering from failures in the 90s. It really does do a great job in an affordable way. It looks to identify where the potential anomalies are and mitigate them before we launch and avoid the 1 in 12 failure rate typical in the commercial industry. And it's also cost effective. I think you know, we do this for on the order of 3% of the stack price, and that's cheaper than you get insurance for. So I think you know, we have a great capability out there, an amazing industry, a lot of dedicated professionals, and a process that works, and that we are able to keep cost effective and not allow to balloon into a very expensive way of doing business.
So you mentioned reuse. As far as the launch enterprise, I understand that you are encouraging reuse, and your current phase is going to be including that. How much money is that saving the government, and do you have any concerns about the reuse?
Yeah, so look, we've baked reuse in the phase 2. We're doing it on the other contracts, and reuse is one of the reasons that we got great prices. It's not the only one, right? I mean, like I said, United Launch Alliance developed their system that used a single booster to meet all NSSL missions. You know, Blue Origin is out there working on the NSSL side of a reusable launch vehicle, but they're also developing an engine that's going to be used on the Vulcan. You know, Northrop Grumman has provided solids that are much more affordable. Aerojet Rocketdyne is on the RL-10. In fact, yesterday we used an additive manufactured injector plate. There's all kinds of those productivity, you know, taking advantage of the latest technologies for productivity being implemented by all those companies, SpaceX, United Launch Alliance, Blue Origin, and the suppliers. So, you know, competition was about making sure we got, you know, reasonable pricing, but it was also about harnessing the innovation, and we really got that in space.
So I think we have our first question from the audience. So Randy Lieberman, if you'd like to take yourself off mute and ask your question.
Yes, thank you, Colonel, for being here and your presentation leading into discussion. Yeah, I know you are not a business entity, but since you've mentioned savings, percentages, so on and so forth, and you're having a choice in years to come of upwards of half a dozen different launch systems, where would you like to see cost per kilo, say 5 years from now, if you could potentially throw that out, because there are some people listening that should hear this, if you can come up with such a number?
Yeah, no, that's a good question. I'm not going to throw out a number, price per pound orbit, because it really depends on a lot of things, right? I mean, what orbit you're going to, and you know, what the really the complexity is. What I look for is, you know, how do we, and you're right, we're not a business entity, but we do worry about our responsibility to the taxpayer. So that's critically important. So what I worry about is, how do we achieve an affordable launch solution? How do we do it in a way that allows you know, the decision makers to decide, you know, you know, which launches need to go when, and how to get it funded without you know, without making that more complex. And then again, I think the key part to this is trying to ensure that we can have you know, commercial-like pricing for orbits that are commercial-like, and then but also get the savings we need on these orbits that are really tough to get to. And I think there's a lot of opportunity to do that in the future with some of the things that our other partners are doing, like NASA. I mean, I think there's a lot of opportunity to continue to drive, for the U.S. launch industry to continue to drive to affordability, and that affordability not just to commercial orbits, but also to the orbits that we need for national security.
Thank you.
So, Justin, we have a question from you. If you could take yourself off mute, please.
Thanks for joining us today, sir. The main question I had is just kind of looking at how you kind of assess risk, or kind of what's your approach to risk when you start looking at these newer, or even just looking at small launch and tactical launch in general as new approaches versus NSSL launch, and that's where I guess I'm to be more specific, just with things being more established in NSSL, like how do you kind of look at those things and kind of push people to the right, so to speak, and how do you think about that?
Yeah, okay, so I'm going to break down in two parts. On the small launch side, we are able to handle risk through a mission assurance process that goes all the way from accepting a large amount of risk to almost the same amount of mission assurance we'll do on a national security space launch. So we have the expertise in the unit to kind of understand how to work in all those regimes. But when you get into national space launch, you just have a different parameter. So we do look to make sure that we're affordable. We have we have processes in place to make sure that we're not doing activities over and over that don't reduce the risk any further. That once we've done them once and if nothing changes, we don't need to do them again. One of the reasons we can fly 5 launch systems right now is because we've saved so much money on being able to do the Atlas and Delta. Not so much money, but we use so many less resources that we can bring on and do the non-recurring and recurring of the new systems, kind of without asking for more resources. So I think I'm answering your question. We don't adjust necessarily do a risk adjustment launch to launch in NSSL, because launch to launch is important in NSSL. If we have a mission that's right behind another mission that's not ours, but that mission has an issue, we have to resolve to achieve the rate we have. We have to resolve our understanding of whatever happened on that prior mission and get to a risk posture we can accept before we go. So we're not going to on NSSL necessarily change dials, but we are going to always be looking at how we're doing it and how we're maintaining that risk posture, and that we're not doing it in an efficient way. So hopefully that answers your question.
The next question is from Danny Lenz. Danny, if you could take yourself off mute.
Hi, thanks for doing this. I was wondering, on the SpaceX STP-2 mission, you were able to do a contract mod and let them try out reuse under the OSP program before doing it on NSSL. I was just wondering if you could comment on how useful that ability is under the OSP program, and when do you think we might see side boosters reused under the NSSL program?
I'm just drawing a blank. We have reused on phase 2, ordered on Heavy, and I'd have to get which one it is. But so that's already there. On OSP4, it's interesting, or OSP3, it was when that one was bought under. It's interesting the way you asked that question. I will tell you, yeah, we worked with them a lot on that mission. That order was there for exactly that purpose, to work with them to understand both us understand the Falcon Heavy, and for them to work with us and understand what we'll be looking for in the future. But that actual change is not, I guess, we always look, as we're executing launches, what's going on, and we're trying to figure out how it's the best way to execute those launches. And that opportunity presented itself in that launch flow. It was a mission that we were clearly willing to work with them on that, so we took advantage of it to work with SpaceX and really, just that was just an exciting launch, and understand what, that was just a huge step forward in our understanding of what it's going to take for us to do national security level risk on previously flown hardware.
Our next question is from John Mayberry.
Hi, Colonel. Appreciate the briefing. Yeah, my question was on Cis-lunar. There's been a lot of interest in Cis-lunar missions for both government and commercial interests. And I was wondering, how is the Cis-lunar launches going to affect the launch programs, or if it does, how will that happen? Thanks.
Yeah, that's a good question. So I think I think that we have a lot of the future is being defined right in front of us, right? So we have a lot of those kind of discussions going on, where different orbits than we traditionally go to are being requested. So really what we need to do is, and it's part of the phase 3 planning, and it's certainly part of the planning for beyond phase 3 even. We have to step back and look and see, well, what's really needed to get to those orbits? Are those capabilities met by the current systems, or, like I said in the talk, is there places we need to invest, whether it's in the part of the system that gets from Earth to orbit, or whether it's stuff you do on orbit, or whatever. And I think Cis-lunar falls into that category. Are we going to need it? How much are we going to need it? And what can our current systems do? And what can't? If they can't do what we need, what do we need to do with industry to make it happen?
Okay, our next question is from Jade Pomelo.
Thank you for your time. You mentioned you talked a little about rapid launch. I just wanted to talk a little more about it, and specifically your thoughts on why follow up to launch time, and thoughts on launch from or locations.
I think where we are in this whole process is understanding what's really needed. And so, I'm sure as a program manager, it's not a shock to many people. I'm a person that likes to see us try to do things and understand what that means, and then we can go off and figure out what we really need. And so, what I've been encouraging is taking advantage of our current activities and finding ways to demonstrate, whether it's a short call up, days to weeks kind of call up, or it's, you've heard me talk about the rapid contracting, where, those kind of things. I just think all that, there's a lot of discussion on what are the requirements, but I think we're still in the phase where we kind of need to, just demonstrate and take advantage of what we're already doing, and figure out, what works and what provides warfighting capability, and what really is not needed or is too much. The other big part of this is affordability. Large complex satellites are going to naturally take longer to get to orbit than, or even multi-missions are going to naturally take a little bit longer, but maybe they're the answer. Maybe it's small launch done in volleys, but they all have, I haven't seen all the work done yet to even really understand what, how that's all going to work. So those are my thoughts.
I think we have time for one more audience question. So Stephen Clark, would you like to take that question?
Colonel Bongiovi, thank you for taking our questions. Just wanted to get your current assessment of when we might expect to see the first NSSL missions flying on Falcon Heavy and Vulcan. I know there are a couple on Falcon Heavy that were later this year. At my last check, are those still scheduled later this year? Just update me on when you expect those missions to fly. Thank you very much.
Yeah, sure. So the first Falcon Heavy is still scheduled for late this year. The second one is moved into 22. And then the first Vulcan is now in early, for NSSL, is in early 23. So that's when those dates are lined up. That's the SF-44 is the first Falcon Heavy, and USSF 106 is the first Falcon, or first Vulcan. Excuse me.
Okay, well, I'd like to take the last question. Some agencies use delivery on orbit as a contracting means versus the NSSL contracts, and they cite lower cost of faster service. Is Space Force looking at other contracting means to lower the cost of launch and to go faster?
Yeah, so I'm not going to talk about other agencies' plans, or all I'll say is that we work with all of our customers to help them find the best launch solution they can. The Phase 2 contract, though, I really do think it brings that structure brings tremendous benefits to our customers. We do have commercial-like pricing for commercial-like orbits. We've really reduced the cost of the highest performing, higher energy orbits. Getting to those orbits is much different under Phase 2 than it was in the past. We've been able to build into the contracting technique launch services that can launch in as short as 12 months. We're able to swap payloads in certain scenarios. We're able to add rideshare payloads. We have all the mission unique or competitively priced in. And then the biggest advantage, of course, is the mission assurance process we have. That process and the dedicated people that run it are why we have the mission success rate we have. And we've really tried to do this, that it's as frictionless as possible to our customers. There are that's really our goal. As far as what does the future contracting look like? Well, that's I think we need a little bit more time under our belt with Phase 2 to understand how that contract's executing and how it serves our customers before we can sign up to yes, that's the way to go in the future, or no, we need to do a different technique. And we certainly are looking at that already and trying to gather that data. And we'll do that in conjunction with our stakeholders and industry.
Okay, wonderful. Well, unfortunately, I think we could probably take one more question from the audience, and let me see who that is. No, actually, I do not have another question. So with that, I want to thank you very much, Colonel, for taking the time out of your very busy schedule to meet with us and to answer your questions. I also want to thank ULA for sponsoring today's event and for identifying this and inviting this wonderful speaker. It really was a pleasure. We do have a couple of exciting events to announce coming up, and first of which is next week on May 26th, we have Alicia Brown, who's the lead of NASA's Legislative and Intergovernmental Affairs Office. She'll be joining us on Wednesday, and then the following month, I wanted to let you know that we have our WSBR silent auction coming up on June 16th. This is going to be a very exciting event. This is an opportunity, again, for us to raise funds for our education programs. We will be opening the silent auction bidding the week prior, so on June 9th. And this will be done as a virtual bidding event, but it will conclude with the event on June 16th. We don't yet have the speaker details ready to announce, but we will be posting that on our website. So look forward to those two events next week on the 26th with Alicia Brown, and then our silent auction on June 16th. So I want to thank you all. It's been I said this last month, it was a record turnout last month, and it's an even higher record this month. So I really appreciate everybody's attendance and support of WSBR. So thank you, Colonel, once again, and thank you to the audience for attending.